class, I am Ejiro Efere. Today we shall continue our lesson on the topic Environmental Hazard 1. This is the third part of this lesson, and we shall continue our discussion on soil erosion and flooding. Remember, this topic is found in the theme Learning about our environment. By the end of today's lesson, you should be able to explain what a drainage pattern is and give some examples of drainage pattern. You should also be able to identify some human activities that can promote flooding and discuss the effects of flooding within an environment and describe the different methods that can be used to prevent and control flooding within an environment. In our previous class, we were introduced to the term flood and flooding. We started a discussion on flooding. We said flooding is a situation in which a usually dry area of land gets covered by large amounts of water beyond its normal limits to a point where it becomes a problem to the environment and to the organisms that live within such environment. We say flooding is an environmental hazard that could be caused by natural factors as well as some human activities. Some of those natural factors that could cause flooding include heavy or prolonged rainfall, overflow of water bodies, strong winds that occur in coastal regions, and we also have the melting of ice and snow. Beyond all of these natural factors, we mentioned that certain human activities could promote the occurrence of flooding within an area. These human activities could do this especially if they interfere with the drainage systems or the drainage patterns of such area. So in today's class, we are going to be looking at the drainage pattern as a way to begin. Then afterwards, we are going to look at some of these human activities that could promote flooding and some other points. Let's begin with drainage patterns. A drainage is a well-defined channel that helps to transport water away from an area. Take note, there are different kinds of drainages. We have some examples here. We have man-made structures such as ditches, trenches, gutters, and so on. We also have natural drainage channels like the overland water flow paths. This is a natural drainage pattern that is found naturally within an environment. You can see an example or an image of overland water flow path. This is found within every area. If rain falls within an area, usually there is a path through which water will flow without creating artificial drainages like gutters, ditches, and trenches. Water will flow along a path on the surface of the land. This path is called the overland water flow path. Drainages help to transport water away from an area. They help a lot to prevent flooding. Usually, these drainages will carry water from an area down to nearby water bodies like streams, rivers, lakes, and so on. Now, let me explain this. Usually, within an area, you have different drainages coming together to link up to a major drainage that flows down to a water body. Say you live within a community, you could find certain numbers of drainages within your own area. The street after you could have its own drainages. The street before could also have its own drainages. Usually these drainages will link up to one another. Drainages from your street could link up with those from the next street and the other street and so on. And when they link up together, they could continue linking up until a major drainage will help to carry the water from that entire area down to a water body. You may not know these water bodies, but this is how it works. So drainages will help to transport water from an area down to a stream, a river, a lake, or whatever water bodies that may be located within such areas. Now, when the water gets to these streams, what happens to them? Streams, rivers, lakes, and all kinds of smaller water bodies also connect with one another in different patterns. Say you have a stream within an area. The drainages would help to channel water from the living area, that's residential areas, down to the stream. When the water gets to the stream, sometimes it will flow down to a river, and from the river, it could also flow down to larger rivers and so on. They connect to one another in different patterns, and these different patterns are referred to as drainage patterns. So that's why we are learning about drainage patterns. Drainage patterns simply refer to the patterns that are formed by the network or the link up or the connections of rivers, streams, lakes within an area. So we can simply say a drainage pattern is the network that is formed between different water bodies within an area. These drainage patterns are also called river patterns. People also call them river patterns. There are different types of drainage patterns. Some examples of these drainage patterns include dendritic drainage pattern, trellis drainage pattern, parallel drainage pattern, centripetal drainage pattern, and we have radial drainage pattern. We're going to be looking at all of these different kinds of drainage patterns one at a time. Let's begin with the first, dendritic drainage pattern. I'd like you to pay attention. These are simple illustrations. In this kind of drainage pattern, that is the dendritic drainage pattern, you have rivers and streams and lakes link up to one another in such a way that they form branches of a tree. They appear like the branches of a tree. Rivers and streams connect to one another and they give an appearance that looks like a tree with various branches. Let's look at the images. You can see what a dendritic drainage pattern could look like. Doesn't this look like a tree with different branches and different connections? You see, this looks like a tree, what a tree would appear like. This also looks like the different branches of a tree. You can see different branches. It's giving off different branches just like a tree. So when you find a pattern or river pattern whereby different branches of streams and lakes are connected to one another to give us the appearance of a tree with so many branches, we say that is a dendritic drainage pattern. Let me mention here that these drainage patterns cannot be observed just by looking around your environment. Let me also mention here that you may not be able to see all of these drainage patterns by merely looking at the rivers and streams within your environment. If you want to see them clearly, then you have to examine the map that shows the connections of rivers or streams or other water bodies within a city. So we move over to the second type of drainage pattern. This is the trellis drainage pattern. The trellis drainage pattern is a kind of drainage pattern whereby streams and lakes and other smaller water bodies connect to the sides of a larger river or a big river. So we have smaller water bodies like streams connecting to the sides of a larger river or a large river. So let's take a look at the image. This is an example of what a trellis drainage pattern would look like. You have a very long river that seems to be flowing across a large area of land. Maybe it's flowing from one community to another, maybe from city to city or state to state. Then you could have smaller water bodies like streams and smaller rivers connecting to the sides of these large rivers. Here is also an example of what a trellis drainage pattern would look like. You have a very long river that seems to be flowing to a particular destination. Then you have smaller ones connecting to the sides of the major river. The next one is radial drainage pattern. Radial drainage pattern is simply a form or a type of drainage pattern whereby streams and lakes flow outward from a high central area like the spokes of a wheel. Take a look at what a wheel would look like, the wheel of a vehicle tire. You have spokes radiating from it, different spokes radiating from the center of the wheel. So this is what a trellis drainage pattern would look like. You have a central high area. This area is usually higher than other areas. Then you have streams and lakes flowing down from these higher areas. They are flowing down from the area. You could also look at this image. It may not be too clear, but you can try to make sense out of it. We are saying that this is a higher area and you have rivers and lakes that are flowing down with different channels from these high areas. This is just an example. We are saying there could be other rivers flowing towards other directions from this high mountainous area. So this radial drainage pattern usually occurs around hills and mountains. You see streams flowing down from a major river at the hill, at the top of the hill or the top of the mountains. You find streams that are flowing down from that major high water bodies. The next type of drainage pattern is the parallel drainage pattern. Parallel drainage pattern is a kind of drainage pattern whereby smaller water bodies like streams flow parallel to one another towards the same direction. They are flowing along the same path towards the same direction to meet with a bigger river. This is what a parallel drainage pattern would look like. You have smaller water bodies flowing along the same path. This is a water body flowing along this path. You could have another one flowing along this path. What you're saying is they are all flowing along the same path to meet with a larger river that could be somewhere ahead. This is just an illustration. The last we shall be looking at in today's class is centripetal drainage pattern. This kind of drainage pattern is seen in a case whereby streams and lakes flow inward towards a central low point. This is the opposite of radial drainage pattern. In this kind of drainage pattern, instead of the water to be flowing from a mountain or a hill downwards, it is flowing from a low land inwards into a lower area. So we have, this is the normal land, the level of the land within an area. Then you have a depression, which is like a valley or a groove, a large groove within this area is a depression. You have streams around this community, around this area, another stream around this area, all are flowing down to the valley. So it's also like the wheel of a tire. Say we have a wheel, this is a low land, a valley. You have streams flowing from this area, all of them are flowing down to this valley or this depression inward. So it's opposite of radial drainage patterns. Smaller water bodies are flowing inward into a low point or a depression. Why are we learning about these different drainage patterns? It is important that people understand how rivers and streams connect to one another, because these water bodies help to drain water away from an environment. Remember, we said artificial water bodies like ditches, trenches, gutters, and so on help to transport water from an area down to streams, to rivers, and so on. If these rivers are obstructed, if their patterns are altered, if activities by humans interfere with all of these drainage patterns from the water bodies, it could also lead to flooding. So people should understand all of these patterns that are formed by the connection or network of rivers and streams and other water bodies within an area in order to understand how to plan the towns and cities to prevent flooding. Now let's go straight to some of those human activities that could promote flooding within an area. Remember, we said flooding can be caused by natural factors and it could also be promoted by some human activities. So whenever human activities or natural occurrences interfere with a drainage system or a drainage pattern within a town, say within Lagos City, within an environment, they could obstruct the flow of water within that environment and promote flooding. So any human activity that obstructs the flow of water within a drainage pattern could also cause flooding in that environment. So here are a list of some human activities that could promote flooding. Some of these human activities include poorly constructing drainages, the act of clogging the available drainages, infrastructural development, constructing impermeable surfaces in developed areas, and damages to dams. The activities that lead to climatic change could also promote the occurrence of flooding within an area. So let's see how all of these factors or these activities could promote flooding in an area. The first one is the act of poorly constructing drainages within an environment. We mentioned earlier that artificial drainages are those drainage systems that are made by man, constructed by man. When these drainages are not well constructed, we say they are poorly constructed. This could cause flooding because they may not have the right capacity to properly drain water away from an area. In a case where certain number of drainages have been made within this area, this town or this city or this community, it is expected that during rainfall, these drainages should help to channel water away from this area into water bodies like rivers and streams in order to prevent flooding. But when the drainages within this area are not well constructed, they are poorly constructed, they may not have the capacity, the right capacity to help to drain water from this area. What will happen? This could lead to flooding. Sometimes these drainages may be too narrow, or too shallow. Sometimes they are too bad that they could get damaged easily or they could get blocked easily. All of these could lead to the occurrence of flood within this area, could lead to flooding within this area. So we are saying drainages should be well constructed. The second human activity that could promote the occurrence of drainage is the clogging of the available drainages. In this case, the drainages were well constructed, but certain human negligence, human poor attitude and all that could lead to the clogging of these available drainages. So when large amounts of sand or refuse are allowed to get into drainages, we're referring to well-constructed drainages in this case, these drainages could become clogged, they will get blocked. They could get blocked by refuse, by sand, and so on. All of these things, as the refuse and the sand, could remain in the drainages and they could obstruct the movement, they will block the movement of water along such drainages. And when this happens, it could lead to flooding. So this water will begin to flow slowly instead of flowing at a high rate in order to carry water away from that area. Now take a look at some drainages in your environment. Sometimes you find most of them clogged or blocked by refuse, by sand, and by different kinds of materials which people throw or they drop in these drainages. It is not supposed to be so. These could lead to flooding within such area. When heavy rain falls in such an area, or during the melting of ice, large amount of ice melts within an area, these clogged or blocked drainages could become filled up with water within a short period of time. And when this happens, they can no longer channel water away from that area because they get filled up easily. So imagine this kind of drainages. During rainfall, it is possible that these drainages, because it has been filled with different materials, it has been filled with refuse, with sand, they could get filled up easily and they could lead to flooding within an area because they are clogged up. Infrastructural development could also cause flooding within an area. This is a human activity that could promote flooding. Sometimes people build houses, they build roads, they build industries, and various kinds of structures along waterways. They build them across waterways, along water paths. They even build them on drainage paths. You see people trying to subfill water bodies, they're trying to subfill streams and so on, obstructing the natural flow of water within an area. This is not right because it could lead to the occurrence of flooding in the future. So people try to build structures even in rivers, streams, and so on. They obstruct the natural drainage pattern and this could result in flooding. Another factor or activity that could promote flooding is the construction of impermeable surfaces within an area. This is often seen in developed cities, cities that are well developed. In such cities, you find the streets, the corners, the neighborhoods, and every area within such cities covered with either they are tarred or they are covered with cement. The surfaces are not exposed. You won't see the soil on such area. All the soil surfaces are either cemented or covered with coal tar and so on. These areas are likely to get flooded whenever it rains heavily or whenever it rains for a long period of time. Why is this so? This is because such soil coverings, such surface coverings like the coal tar and the cement absorb water at a very slow rate. They absorb water at a very, very slow rate. So instead of the water to be soaked up by the soil, absorbed by the soil, it will take a long time for this water to pass through the cement or through the coal tar into the soil. Therefore, these could cause flooding because it will cause accumulation of water within an area. Just imagine if rain should fall in your room. What will happen? You have large amounts of water accumulating in your room because the surface of the soil in your room has been covered with cement or whatever material. These materials do not absorb water easily. They take a long time to absorb water. So water could accumulate in such areas and lead to flooding or promote flooding in that kind of area. We could also see a case where damaged dams could promote the occurrence of flooding within an area. What are dams? Dams are simply walls or barriers that are built across a river or across any water body to stop the flow of water. They can also be built to hold up water. They are built sometimes to stop the flow of water or sometimes to hold up water. These are images of what dams look like. You can see a large water body in this area, and this is a wall or a barrier that has been built across the water body. Now you can see water flowing from this water body, let's call this a river, flowing from this river into this open area. This is because a wall has been built on this part, which acts as a barrier. It helps to hold back water, to stop water, or to help to channel water to a particular area. This water can be used for various purposes. That is, water that is held by the dam can be used for various purposes. Such purposes include generation of electricity. So we can use such water to generate electricity. We can also use it for irrigation purposes. We can also use this water or this wall to control erosion. And it can also serve as water reservoir in a community or in an area. So water can be stored in this area for future use as a reservoir. When dams are poorly constructed or when they are faulty, we are saying that they could lead to flooding. Because these dams usually hold large amounts of water, so when poorly constructed dams or faulty dams hold a very large amount of water, a very large volume of water than they can take, what will happen? They will simply break, just as we are seeing in this case. A dam was constructed here, but because it was poorly built, well, because it was faulty, it broke when large amount of water came or ran into it. So this is what will happen when dams are poorly constructed. They will get damaged, and when they are damaged, of course, large amount of water will begin to flow into nearby communities. So when dams break down, they release the water they hold or that they contain into the nearby community, thereby causing flooding. So it is advised that dams should be well constructed. Any activity that leads to climatic change could also promote flooding within an environment. Human activities such as the burning of fuel in our vehicles, in industries, and so on, could release certain gases into the atmosphere. So several human activities that involve the burning of fuel, whether they take place in the industry or even while we drive our motor vehicles from one place to the other, certain gases are being released into the atmosphere. As this continues to happen, these gases accumulate in the atmosphere over time and they cause changes in climatic condition. This kind of climatic changes could make the environment get very, very warm. So the environment will begin to change over time. Instead of the temperature of the environment to be cold at certain times, they will become very warm. This warm temperature could lead to the melting of ice and ice deposits. It could lead to the melting of snows. It could lead to the melting of glaciers, frozen areas, and so on. And when these different frozen water begin to melt, of course, you know, it could result in flooding. This ice could melt in such a large amount that it could flood an area. Having looked at the various human activities that can promote flooding within an area, I'd like us to see the effects of flooding. What are the effects of flooding? By now, I expect you to know that flooding has a lot of dangerous and harmful effects within an environment. Some of these effects include the following. One is the loss of lives. Flooding could lead to the loss of lives. Some humans and animals usually get drowned during severe flooding. In every community that may have experienced flooding, sometimes you hear that a certain number of humans were killed or a certain number of humans died as a result of the flooding. Animals were destroyed, farmlands and so on were destroyed. So flooding could lead to loss of lives. Also lead to loss of farmland, whereby crops and livestock can be destroyed. Yeah, animals will be destroyed. Farmland could be washed off by the large amount of water. Of course, animals will get drowned in the water as well. Flooding could also lead to loss of properties. Large amounts of water could submerge properties like houses, buildings, other forms of building, cars, poles, electronics in the home, and so on. Sometimes it submerges buildings. So you see in this case where water has almost covered all of the items in this living room. This is how bad it can be. It can also submerge the entire building. In this case, you can only see the roof of these buildings. They are almost completely covered by the water. Flooding can be very, very bad. It could destroy a lot of things within an area. Flooding can also lead to environmental pollution. Yes, It could cause pollution. Severe flooding can cause soil and water pollution, and this can happen as water washes off from industries, as it washes off from various parts of a city or various parts of a town. It could carry along harmful waste substances and harmful chemical substances. It could go to industries, wash off their harmful chemical substances. Imagine sewage and all other kind of harmful waste materials could be washed off by flood into different areas. And as this happens, these could be washed off into the soil, into the water bodies. So even after the flooding may have taken place, you could find all of these water bodies highly polluted. So flooding could lead to environmental pollution. It could also cause poverty and hardship. Whenever severe flooding occurs within an area, within a community and all that, it leads to poverty and hardship. Even after the flood may have taken place, you find that most people would have lost their houses, they may have lost their properties, they may have lost a lot of things, money, food, farmland has been washed off, washed away, and so on. So all the dangerous or the many effects of flooding, like the loss of properties, loss of lives, loss of farmland, and all of that could lead to severe poverty and hardships. After the flooding, people will begin to struggle to survive. They'll begin to struggle on what to eat and so on. This is not so good and it could be caused by flooding. At this point, we're going to look at how to prevent flooding. This is very important. We need to learn how to prevent the occurrence of flooding. At least we should learn the things we can do and try to do them. Some of the ways to prevent flooding within an area is by ensuring the proper use of town planning. We can also prevent flooding by strategically planting trees and protecting wetlands within a community or within an area, by the use of flood embankments, and by building proper drainage channels and ensuring that the old drainage channels are free from refuse and so on. So let's look at the first one. How do we prevent flooding? By ensuring proper town planning. Usually, in a developing city, you find that the government of the city or the state would have a master plan that guides people on how such a city should be developed. This master plan tells you where to build houses. This master plan tells you where to build industries and so on. This master plan is also supposed to create rooms for drainage channels. It's not supposed to allow the building or the construction of different structures on drainage channels. So if people use this town plan, it will help to prevent flooding, because developing towns and cities will be well constructed and they will be properly planned according to the proper town planning charts. In this way, buildings and other structures do not block the drainage systems and they do not obstruct natural waterways. We can also try to prevent flooding when we strategically plant trees and help to protect wetlands. The effect of flooding can be prevented if we as humans try to grow plants and also try to protect wetlands. Wetlands here simply refers to an area of land that is covered with moisture, maybe water, or it is just wet. The surface of the land is just wet. This wetland remains wet all year round. That is why it is called a wetland. So you just find some amount of water on its surface. It is different from rivers, streams, and other water bodies because it is not shallow. It's just like a normal area of land, but its surface is usually covered with water. We need this wetland to help prevent flooding in our environment. So we are saying people should help to protect the wetlands that are found within our environments. Plants can help to restore climatic conditions. Remember, we said the roots of plants could help to prevent flooding. We are saying plants as well can help to restore climatic conditions. They help to absorb some of these dangerous and harmful gases from the atmosphere, thereby preventing those changes that could occur in the climate due to the release of these harmful gases. The wetlands also help to soak up water because these are land that always hold up water. They always have water on their surfaces. Whenever a large amount of water flows to the wetland, they will soak this water up and keep them intact. So this wetland will help to hold up large amount of water. Sometimes people destroy this wetland and they begin to build houses. No, we are saying wetlands should be protected by preventing humans from building or constructing structures on them. We can also prevent flooding by the use of flood embankments. Flood embankments are walls or barriers that are built around water bodies like dams, but in this case, these are not dams. We say they are built around water bodies, are built around the boundaries of water bodies. What do? They act as artificial river banks. Usually when there's an overflow of water, it will flow to the river banks first. But in this case, we are saying because a wall has been built around the boundary of this water body, we are saying the water will flow down to the wall. So we see flood embankments built around rivers, streams, lakes, and so on. What do? They help to prevent the flow of water from these water bodies into neighboring areas, thereby preventing flooding. So if you build walls around rivers, as we can see in this case, build walls around streams and so on, they will help to prevent flood. In times of overflow, instead of the water to flow to the nearby communities, it will get so high to the level of the wall or the flood embankment, then it will go down into the river. Structures like well-constructed dams as well, lakes and retention pond, artificial lake in this case, can also be built around or close to rivers. So sometimes people could decide to build a dam on some part of this river or build an artificial lake around this area of this river in such a way that if this river should overflow, it will flow into the lake instead of flowing into nearby communities to cause flooding. All of these are ways to prevent the occurrence of flooding. Flooding can also be prevented by building proper drainages and ensuring that the old drainages are clean, they are clear, they are free from refuse and any other item that could block them. So we can also prevent flooding by building better drainages and by ensuring that the existing drainages are free from refuse and whatever materials that could block them. This should be done in order to adequately channel water or excess amount of water away from an area into the nearby surrounding water bodies. These drainages should be appropriately covered as well. In some cases, we may have to cover the surface of our drainages. For example, we may have to cover the surface of this drainage to prevent soil or sand from flowing into it during rainfall, from moving into it during rainfall. So we have to cover some drainages, cover them appropriately to prevent litters and sand from getting into them and causing blockage. If our drainages are well constructed, if they are adequately built, they would also help to channel water out of an area in the proper manner. At this point, we'll summarize all we've been learning in today's class. We started by saying drainage patterns are the patterns that are formed by the network of rivers, streams, lakes, and other water bodies within an area. Some examples of drainage patterns include dendritic drainage pattern, trellis drainage pattern, parallel drainage pattern, radial drainage pattern, and centripetal drainage pattern. We also saw some human activities that could promote the occurrence of flooding within an area. These activities include the clogging of drainages, infrastructural development, construction of impermeable surfaces, damaged dams, and so on. Some of the effects of flooding within an area include environmental pollution, poverty, loss of lives, loss of farmland, loss of properties, and so on. Some of the ways to prevent flooding include strategically planting trees and trying to protect wetlands, helping to ensure that drainages are well constructed, the use of flood embankments, and so on. I believe you have learned so much from this lesson, but before we end, I'd like us to take this question. The following are the effects of flooding except dash. A, climatic change. B, loss of life. C, poverty and hardship. D, environmental pollution. The correct answer here is option A. Flooding could lead to loss of lives. It could also cause poverty and hardship, and it could lead to environmental pollution, but it cannot cause climatic change. We have come to the end of today's lesson on environmental hazard 1, where we talked about or we learned about flooding and soil erosion. I hope you enjoyed it, and I hope to see you in our next class. Bye.